I've got a very simple app here. It's kind of a hello world with a little extra something. I'll show you the source code, hello.py. Most of this, let me make it a little bit bigger, most of this is comments and boilerplate, but this is using the Python Flask package to build a simple web app. The main functionality is right here in this say hello function. What this does is it takes a name to say hello to, and the app that calls it pulls off the name value from the URL. So if you specify a suffix at the end of the URL, it'll say hello to that name. Otherwise, if there's nothing specified at the end of the URL, it'll just say hello world. The other cute thing it does is it uses the Python random package to generate a random background color and uses CSS to render that color. That's all it does. And the rest of this is sort of error handling and whatnot. The whole app is only about 10 lines or so of actual, the essence of the code, I would say, is probably only about 10 lines. So let's run that. Python hello.py, and the Flask library starts up and gives me a URL. It's a local URL with port 8080. I'll click on that. And there I get my hello world with a random background color. If I keep visiting it, I get new colors. And if I add something to the end of the URL, like /mark, it says hello Mark. That's all it does, but it's good enough to illustrate the transition I want to show you, which is as follows. Now if I exit out of this, and if we just look at what's going on here, the application is dependent on a couple of Python libraries, which I've enumerated in requirements.txt. So normally if I shared my hello.py source file with someone else, they would have to, at a minimum, run pip3 install -r requirements.txt. Even there, I haven't specified version numbers for these two packages. So they might end up with the wrong version and get different results. Another pitfall is that the environment I'm in right now might depend on a package I don't even realize I'm depending on, and because I've already installed it at some time in the past, it doesn't create a problem for me. But if I share this code with someone who hasn't installed that package, they might run into some runtime problems. So one way to kind of solve this dependency problem is to package everything up in a kind of hermetically sealed modular component called a container. So I'm going to do that. I have a file called Docker file, which is, you can think of this as a blueprint for a container. And it works as follows. I'll walk through these lines with you from Python 3 or Python:3-on build. Specifies the base image for this container. Workdir gives the container a working directory. You can think of this as the home directory for the app. Then I add a couple of source files, specifically the hello python.py and the requirements.txt dependencies. I add those copies of those files to the working directory, run pip install on the requirements, and then I set it up so that the starting command when you actually instantiate the container is running Python with that hello.py source file that I just ran interactively. I've got a helper script here called ldeploy for local deploy. And this does all the Docker stuff, all the commands that I need to create the container and to run it. So we'll run that in a second. But just to explain this, it's taking one argument, which is which container we want it to build. And the reason that's there is I have a Golang version right here, and I have a Python version right there. So there's one little extra level of indirection here to just specify which of those two versions we want to work on. So we set up this tag, which is just an environment variable with a string that we're going to use to identify the container. We say docker build $1, that's the directory. We're going to specify Python there to the directory containing the source. And we apply that tag. That's really just an identification string for the container that we create with docker build. Once it's built, we're going to run docker run, again with the same tag, and that will actually start up the container and run it. We specify this minus P80 8080 colon 8080 colon is to make a connection between the host system's port 8080 and the same port inside the container. So it just becomes sort of a pass-through that any requests coming into that port get kind of piped directly into the same port number inside the container. So let's try running that. And I already forgot to specify the argument Python. There we go. It's running docker build. And it's now run docker run. And we can see it running. If we say docker ps, we see the actual container image running right now. So let's go ahead and connect to it. We're going to run localhost colon 8080. And we see pretty much the same behavior we saw before. I can add a little suffix here. Demo Derby. And we get hello demo Derby. But what's cool is this is running with a complete package of everything that this application depends on. So now I can give someone this container image, and I can be sure that they're going to be kind of experiencing the exact same bit for bit version of the application that I'm testing here. So it really does away with a lot of these dependency issues that you would run into when you share source code. And another nice thing about this is there's nothing special about Python. This works for any language, any environment. I could bundle up a Fortran application with this mechanism and give it to someone else. And as long as it works for me inside this container, it should work for anyone. So it really gives me a lot of power and portability between different systems. But the thing is, I want to now run this in the cloud. I want to deploy this app in the container somewhere convenient where it'll just work and I don't have to think about setting up machines and doing a lot of administration and so on. And that's where Cloud Run comes in. So Cloud Run is a Google Cloud service that gives you the ability to deploy Docker containers in the cloud, where Google will basically take care of all the administrative details of installing it, giving it a URL. Actually, you'll get an HTTPS or an SSL ready URL right off the bat. It runs it whenever traffic comes in, and a key thing is it scales that service so that no matter how much traffic you have coming in, it'll automatically kind of grow and shrink as per the demand that it sees. So I'll just show you how that works now. I have another script similar to, let me clear the screen here, similar to ldeploy. I have rdeploy for remote deploy. And this is using the same Docker file, really all of the code you've seen. I don't have to change anything in order to deploy this to the cloud now, which is quite nice. I simply come up with a project name associated with my Google Cloud experience. I give the app an app name. That's going to be the name we call it when I deploy it. I'm using the same tag that I did before. So that's just the identifier for the container. And then I say docker build -- tag, and then the $1's going to be Python again. The one extra step, or really two extra steps here. One is that I have to push the built container to a container repository, and that's easily enough done with docker push. And then whereas I was just saying docker run before, now I'm saying gcloud run deploy. So this is referring to the run service. That's what the run is, cloud run. And then deploy says take this container, to be specified in a second. Let's call it $app, which is mco hello -python in this case. This is the key argument. This tells it where the image, what the name of the image is in the container repository. So that tells it to use the image we just built and pushed. We're going to use the managed version of Cloud Run. There's a version you can run with GKE directly. This is the managed version. This tells it which region we want to run in, which project to use, some specifics about the how much concurrency we want, how much memory. And importantly, we're going to say allow unauthenticated. So anyone can come along and visit this website once we've set it up. So let's run that script now, our deploy. And again, I made the same mistake. I'm going to give it the which of the two app versions I want, our deploy Python. So it's doing the Docker build. That's going pretty fast. Well, it actually finished. Now, then it did the Docker push, and that finished as well already. Now it's doing the cloud, the G Cloud run deploy step, and you can see this is progressing right away. It's already finished. Really assigning. Well, now it's assigning traffic to the latest target. It's already deployed the service effectively, and now it's come back and given me a URL. So I can click on this, and it takes me to the cloud version of the same app we've been looking at. Let me get rid of this extra tab here. And as you can see, it works just as before. The other thing is I can go into the Google Cloud Console and take a look at my different services. Here's the one I just deployed, mco hello Python. I'm going to refresh this page just to make sure it's up to date. And we should see a last deployment date of a few minutes ago. Here it is again, mco hello Python, and sure enough it says last deployed October 26th, that's today at 3:47. If I drill down into this app, I can get more information about it. I can see some metrics on the usage. I can look at log file information. Revisions is interesting. Every time I deploy a new version of this app, I get a new revision here, and I can do some interesting I can tell the system what percentage of traffic, I guess traffic splitting is probably the term I should use. I can tell the system how to apportion different levels of traffic to different versions, and in so doing, I can do canarying and I can do A/B testing and all sorts of nice capabilities. But as you see, I get a URL automatically. I didn't have to do anything to arrange that, and it's HTTPS, so I automatically get SSL certificate and all that good stuff to do secure web service without really having to think about anything. I can of course click on it from here and it works the same way. The really cool thing about this though is the scaling. So if my web service is a little bit more impressive than the one you're looking at right now and it starts to attract attention and I get a wave of traffic, Google will ensure that the services behind this URL automatically grow and shrink to accommodate the demand. So it won't fall over if you suddenly get sudden surge of popularity, and it'll shrink down to 0 if you find that you don't need all that service running at some point in time. And as a new recently added feature, you can actually specify a minimum number of server instances so that you can guarantee that you'll be pretty responsive when the very first request comes in after you've had very little traffic for a long period of time. And that reduces greatly this issue of cold starts, where the first request in a while seems to take longer than a normal request in the thick of things. One really cool thing about this service is that the whole business with the containers and the Docker file, we've made it so you don't have to think about that either. So even though it wasn't too bad for this application, it would be nice if I didn't even have to understand what containers are or what, I mean, it's helpful, but it would be nice if I didn't have to write a Docker file and have to mess with that. And through something called build packs, we've actually made it so that you don't even need to worry about Docker anymore. We'll take care of that for you. And actually, Katie's coming up with a demo of that, so you can look forward to that. I think it's the next session. That's all I wanted to show you for today. I think it's a really great way to build, deploy, and manage applications, and I hope you enjoyed this. Thanks for watching.